Hey everybody, so in this video we're talking about solving quadratics by completing the square. So before we jump in and start working on these problems, I kind of want to tell you about completing the square and why this is a useful technique that we learn. So one thing about completing the square will find the solutions to any quadratic, and it will always work. Even if the quadratic as it's written is not factorable, completing the square will always give you the solutions. So let's talk about the end goal of what we're trying to do. Completing the square is trying to create what is called a perfect square trinomial. So let me give you an example of those. X squared plus 4x plus 4. This is a perfect square trinomial. Now, I'm going to write a few examples and I'm going to see if you can distinguish about what makes a perfect square trinomial. What about this one? X squared plus 6x plus 9. That's a perfect square trinomial. X squared plus 10x plus 25. This is a perfect square trinomial. Last one, x squared plus 12x plus 36 is also a perfect square trinomial. All of these are perfect square trinomials. Okay, so when I say what is a perfect square trinomial, what is it producing? It's producing factors that are identical. So let's look right here. If I said factor this, what are two numbers, right? Two factors of 4 that multiply to give me 4. This would be x plus 2 and x plus 2, right? And then I could write it as x plus 2 quantity squared. So this is a perfect square trinomial and it gives factors that are the same. Same thing here. What are factors of 9 that I can add to get 6? Well, that would be x plus 3 and x plus 3. And then notice it's the same thing here. What are factors of 25 that add to give me 10? 5 and 5. What are factors of 36 that add to give me 12? 6. So it'd be x plus 6 and x plus 6, right? Now, have you noticed anything about the b and c term, right? Because there is a pattern with each trinomial. Here's what you do. You take the b value, half it, and square it. What's half of 4? 2. What's 2 squared? 4. What's half of 6? 3. What's 3 squared? 9. What's half of 5? What's half of 10? 5. What's 5 squared? 25. What's half of 12? 6. What's 6 squared? 36. Anytime you have a perfect square trinomial, it is factorable and you'll always get factors that are identical. Now, it is very easy to create a perfect square trinomial. So let's look at this example. We know this is factorable because if I can think of values that are the same, factors of 27 that I can add to get negative 12, that's going to be 9 and 3. Okay, so we know it's factorable. But what if we had something that wasn't factorable? Like, are there factors of negative 50 that I can subtract and get 2? Maybe, maybe not. So here, this is not the number I want. I want 36, not 27. So I'm going to start by subtracting 27 from both sides. Now I have x squared minus 12x. Notice how I'm intentionally going to leave space here. And this equals negative 27. Now, we want to create a perfect square trinomial. So the process is the same on how to do that. Take the b term and cut it in half. So here, negative 12 cut in half is negative 6. I'm going to take the negative 6 and square it. What's negative 6 squared? 36. So I wanted this to be 36, and you can't just randomly do something to the left side and not do it to the right. So if I add it to one side, I must add it to the other. And now I have my perfect square trinomial. X squared minus 12x plus 36 equals, and then here we have negative 27 plus 36. And that's going to give me 9. Now, I still want to find the solutions. I want to solve this. So I can solve this by factoring. So what are factors of 36 that will add to give me 12? Well, we already talked about that. It's going to be 6. So here we have x minus 6 and x minus 6. And we know we can rewrite this as x minus 6 quantity squared equals 9. So we can solve this using the square root method. So we're going to take the square root here and the square root here, and we have x minus 6 equals plus or minus 3. And now we can find the value of x, because all we need to do now is just add 6 here. So x is equal to 6 plus or minus 3. So my two solutions will be 6 plus 3 and 6 minus 3. So I'll write those right here. So my solutions are going to be 6 plus 3, which is 9, and 6 minus 3, which is 3. Now, here you can get those same numbers by factoring. And I know you're thinking, why on earth would I go through this if I could just factor? What if the trinomial, as it is not factorable? So here, we're looking at negative 50. Are there factors of negative 50 that I can subtract and get positive 2? Here, this as it stands is not factorable. So we can make it factorable by creating a perfect square trinomial. So this is the wrong number. So let's look at the b term. Cut this in half. What's 2 cut in half? It's 1. What's 1 squared? 1. Okay, I want this to be 1, not negative 50. So I'm just going to move it, right? Just going to play around with my algebra here. I'm going to move 50 to the other side, so that way I'm just left with the x squared and the 2x. So I have x squared plus 2x. I'm intentionally going to leave some room here. Negative 2 plus 50 is 48. Now we've already said we want this to be 1. So here I'm going to add 1, and I can't just do it to the left. I also have to do it to the right. So I'm going to add 1 to both sides. And now I have x squared plus 2x plus 1 equals 49. Now I've created a perfect square trinomial. My factors will be the same. So here we should be seeing that this is going to be x plus 1 and x plus 1. So here I have x plus 1 quantity squared equals 49. And now I can simply take the square root of both sides. So I have x plus 1 equals plus or minus 7. And now I can find the value of x by subtracting 1. So x here is negative 1 plus or minus 7. So now x is going to equal negative 1 plus 7 is 6. Negative 1 minus 7 is negative 8. And again, here you could have taken the negative 2 and you could have added it to both sides, and then that trinomial would be factorable. That's fine. But what we're doing is we're building a skill set so that it doesn't matter what trinomial we have, we can make it factorable. So here, we need to write this in standard form. So we have x squared. This 18x needs to come over here. So we're going to say minus 18x. And then this 9 we want to come over here as well. So we're going to say plus 80 equals 0. Now, let's take 18 and cut it in half. What do we get? We get 9, or negative 9 rather. What's negative 9 squared? 81. Okay, this is not 81. So I want to solve this by creating a perfect square. So I'm going to move the 80 over here. So now I have x squared minus 18x, intentionally leaving room, equals negative 80. So we've already said we want 81 to go here. So here we're going to add 81 to both sides. Now I have x squared minus 18x plus 81 equals 1. And now I can factor this. What are factors of 81 that I can add and get negative 18? And that's going to be x minus 9 and x minus 9. So because the two factors are written the same, I can say x minus 9 quantity squared equals 1. I can now solve by the square root method. So I'll take the square root of both sides. X minus 9 equals plus or minus 1. And now x is equal to 9 plus or minus 1. So here I can write this as 9 plus 1, 9 minus 1. These would be my solutions. Now, let's look at a few where the solutions would not be integers. So here with number 1, we want a perfect square trinomial, because that's how we're going to solve by completing the square. So let's start with negative 2. Let's cut it in half. We get 1. 1 squared is 1. We want this number to be 1, not negative 4. So we'll start by adding 4 to both sides. So here we're getting x squared minus 2x, intentionally leave room, equals 4. We've already said we want this number to be 1. So here we want to add 1, add 1. Now we have x squared minus 2x plus 1 equals 5. So now I want to factor this. So what are factors of 1 that I can add and get negative 2? Well, that's going to be negative 1 and negative 1. So this is going to be x minus 1 quantity squared equals 5. I can solve by taking the square root. So I have x minus 1 equals plus or minus the square root of 5. So this is not a perfect square, so I'll just leave it under the radical, and I'll add 1 to both sides. So x is equal to 1 plus or minus the square root of 5. Now here I would say this is fine just to go ahead and leave this in the curly brace, unless you're on some type of computer software where they want you to, separate both solutions using a comma, and then you would have to say something like this. You would have to say 1 plus the square root of 5 and 1 minus the square root of 5. All right? Now, this is still very useful, even though this was not factorable. There are not factors of 4 that you can subtract and get negative 2. All right? So this is not factorable, but I was still able to find the solutions using completing the square. So that's why we really like completing the square. It works on everything no matter what. Again here, factors of 46. Can you think of factors of 46 that I can add together and get 16? No, right? So this is not factorable, but I can still find the solutions by completing the square. So let's think. What's 16 cut in half? 8. What's 8 squared? 64. That's what we want to go here, not negative 46. So we're going to start by moving 46. So now I have x squared plus 16x equals negative 46. Again, we want 64 to go here. Half of 16 is 8. 8 squared is 64. I cannot add it to one side without adding it to the other. Remember, that's called balancing equations. So now I have x squared plus 16x plus 64 equals 18. Now this is a factorable trinomial. So what are factors of 64 that add to give me 16? And that will be 8. So here this would be x plus 8 and x plus 8. So I can write this as x plus 8 quantity squared equals 18. Now I can solve by taking the square root of both sides. So now I have x plus 8 is equal to, now simplifying the radical here is purely up to your teacher. Okay, I am going to simplify in this video, but remember, this is the exact same thing as 3 root 2. They are the same number. You do not have to simplify for it to be numerically correct. So here, this is going to be plus or minus 3 root 2, and now I can subtract the 8. So x here is equal to negative 8 plus or minus 3 root 2. And this will be your two solutions, negative 8 plus 3 root 2 and negative 8 minus 3 root 2. All right, last example. Again, we want this in standard form. So we have x squared. We're going to add the x over here. So that gives us 8x. And then this 66 needs to come over here. So 7 minus 66 is going to be negative 59. Can I come up with factors of 59 that subtract to give me 8? No, we cannot. So as it stands, this is not factorable, but we can still find the solutions by creating a perfect square. So if we cut 8 in half, that's 4. 4 squared is 16. We want 16 to go right here. So we're going to move this 59. This is going to give us x squared plus 8x equals 59. So we've already said we want 16 to go here, so I can add 16 to both sides. So now I have x squared plus 8x plus 16 is equal to 59 plus 16 is going to be 75. And now what are factors of 16 that can add to give me 8? That's going to be 4. So I have x plus 4 and x plus 4. You should be noticing that anytime you use completing the square, the factors of this trinomial are always going to be the same because we're going to use the square root method to find our answer. So here we have x plus 4 equals 75. You should also be noticing that this number is always going to be this number cut in half. Right, so the number that goes in your parentheses is always the b term cut in half anytime you use completing the square. Because what was 16 cut in half? 8. What was 2 cut in half? 1. It always works. So now we'll solve by taking the square root. So I'll take the square root of this side. So now I have x plus 4 equals, again, you do not have to simplify to be numerically equal. I will simplify for the purpose of this video. So that would be 5 root 3, and then I can subtract 4. So here, x is equal to negative 4 plus or minus 5 root 3. And these are my solutions. So this is how we solve quadratics using completing the square. Completing the square is incredibly useful, again, because it always works. There is not a single quadratic trinomial that I cannot find the solutions to using completing the square. It is a solid. It always works. Factoring is fastest if you can think of factors that multiply to give you the b term. If that is something that you struggle with, then this process may be something you want to get good at because it always works. All right, that's going to be it for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.